Good morning to everyone. Last video we have seen about the how we solve the one-dimensional bar element for finding the primary unknowns and secondary unknowns. In this up to we can discuss for an global stiffness matrix. In this video we are going to discuss about the how we apply a boundary conditions and finding the primary unknowns and secondary unknowns. So the general finite element equation is force vector equal to stiffness matrix into displacement vector. So already we find the global stiffness matrix. So that will be an 25 into 10 to the power 5 minus 25 into 10 to the power 5 0 minus 25 into 10 to the power 5 40 into 10 to the power 5 minus 15 into 10 to the power 5 0 minus 15 into 10 to the power 5 15 into 10 to the power 5, and then the displacement will be an u1 u2 u3, and then the force vector will be an f1 f2 f3. Now we are applying as an boundary conditions. The node 1 is fixed, so the u1 will be an 0, and then f1 f2 force will be an 0. In node 3 the external force applying as an 73 kilonewton, that will be converted into a newton, so 75 into 10 to the power 3. So based on the node 1 deformation 0, corresponding element row and column will be negligible based on the Gaussian element procedure. So first row first column cancel, remaining 40 into 10 to the power 5 minus 15 into 10 to the power 5 minus 15 into 10 to the power 5 15 into 10 to the power 5 u2 u3 0 75 into 10 to the power 3. Is solving this matrix, we want to convert into an equation form. So 40 into 10 to the power 5 into u2 minus 15 into 10 to the power 5 into u3 equal to 0 minus 15 into 10 to the power 5 u2 plus 15 into 10 to the power 5 u3 equal to 75 into 10 to the power 3. Solving this equation, we can find the u2 value is 0.03 mm, and then u3 will be an 0.08 mm. So this is the primary unknown of that particular component. So displacement. So the node 1 will be fixed, so u1 will be 0, u2 will be an 0.03 mm, u3 will be an 0.08 mm. So this is the primary unknown variables. Next we want to find the secondary unknown variables. So either if we want to find the stress values, strain into Young's modulus, or otherwise E divided by LE minus 1 u1 u2, because element 1 will be in the displacement will be u1 u2, node 1 and node 2. So Young's modulus 2 into 10 to the power 5, length 120 minus 1 the displacement of node 1 will be 0, node 2 will be 0.03. If we multiply these values, 2 into 10 to the power 5 divided by 120, the value will be in 1666.66. So multiplying the inside of the matrix, so minus 1666.6 plus 1666.6. Then we want to multiply this two matrix, minus 1666.6 into 00 plus 1666.6 into 0.03, 50 Newton per mm square. So this is the stress of element 1. Next stress of element 2, Young's modulus will be an 2 into 10 to the power 5, and then the length will be 150 mm minus 1 for element 2, node 2 and node 3, so u2 and u3. So multiply and dividing of this 2 into 10 to the power 5 divided by 150, the value will be an minus 133.33 plus 133.33, and then 0.03 0.08. For multiplying minus 133.33 into 0.03 minus 40, multiplying of 133.33 into 0.08 106. So final value will be 66.6 Newton per mm square. Then we want to find the reaction force. So reaction force equal to stiffness matrix into displacement vector minus force vector. So based on that equation, so 25 into u1 10 to the power 5 into u1 0 minus 25 into 10 to the power 5 u2, the u2 value will be 0.03. So minus 25 into 10 to the power 5 into 0.03 minus 75 into 10 to the power 3 Newton. So thank you for watching this video. We'll see you in next video.